These are the solutions to the quiz questions at the end of lesson 5.2. Now for number 1. The pair in case A both have their north poles on the right-hand side using the right-hand grip rule. So that means a north pole is near a south pole in the middle there, so they are attracted. But the pair in case B, the left-hand magnet has its north pole on the left, and so its south pole is nearest the other magnet. The right-hand magnet has its north pole on the right, so its south pole is nearest the other magnet. So those two souths will be repelled. So the answer there is B. Now for number 2, a solenoid has a field like a bar magnet so that it runs down the middle of the loop, and that means it's parallel to the current. So 0 force, and the loop is not affected. So that is option E. Now number 3, so 1 was B, 2 was E, 3. So 3, that is D, because if your fingers are pointing to the left and the current is down the page, that means the wire is pushed into the screen, which means downwards. Now number 4, for both B and D, the wire is at right angles to the magnetic field. So they're both equal. Then we have that they are larger than the case in A because it's at an angle. And then that is larger than C because C is where it's 0 since they're parallel. Now for number 5. The vertical component of the magnetic field is parallel to the current, so there's no force from that. We're only interested in the horizontal component. So that, we'll call it BH, is 1.8 by 10 to the minus 5 Tesla. Then we have the current is 28 amps. And we have a length of 6 meters. Now we know that the force equals I times L times B. So we have 28 times 6 times 1.8 by 10 to the minus 5. That is 0.0030 newtons, or 3.0 by 10 to the minus 3 newtons. And the direction, it will be to the east. Now number 6, we have a number 1200 of turns. We have an area of our coil of 1.1 by 10 to the minus 2 square meters. The torque is 5.8 Newton meters. B is 0.2 Tesla. So we know that the torque is N I A times B, and therefore we have current equals torque over N times A times B. So that will be 5.8 over 1200 times 1.1 by 10 to the minus 2 times 0.2, and that gives us 2.2 amps. And number 7, we've got 2 loops, and each of them will make some magnetic field. So one will be, the one from the horizontal loop will be upwards, the one from the vertical loop will be to the side. So we're going to end up, if we call it B from each one, then the total will be square root of B squared plus B squared, which is square root of 2B squared, so that gives us root 2 times B, since that's the hypotenuse. So let's find B, which is due to one loop. So we have R equals 4 centimetres, which is 4 by 10 to the minus 2 metres. N equals 1. I equals 1.7 amps. So B, which is mu naught I over 2R, will be 4 pi by 10 to the minus 7 times 1.7 over 2 times 4 by 10 to the minus 2. And that gives us 2.7 by 10 to the minus 5 Tesla. So then our total B is root 2 times that. Let's call that B total. Root 2 times B will be 3.8 by 10 to the minus 5 Tesla.